Good day, everyone. I am Roldan C. Bangalan, a faculty member of the School of Arts, Sciences, and Teacher Education of St. Paul University, Philippines, Tuguegarao City. My fellow attendees, I'm glad to share with you my paper titled Online Learning Mindset, Mathematics Outlook, and Academic Performance of College Students in a Fully Online Flipped Math Course. Here are some snapshots of my university, St. Paul University, Philippines, dubbed as a university in a botanical garden, and it is also a historical landmark. The COVID-19 pandemic have caused educational disruptions which compelled schools and universities to close their campuses. For teaching and learning to continue during this disruptive era, most universities have shifted to online mode of teaching and learning. Now, teachers and students are getting into the rhythm of teaching and learning from home. And with distance learning set to continue, it is an ideal opportunity to try out pedagogical approaches which encourage independent learning among students. One promising strategy for promoting online active learning is the fully online flipped classroom pedagogical approach. An online flipped classroom is a variant of the conventional flipped model. The online flipped classroom is similar to the conventional flipped classroom model in that students are encouraged to prepare for class by completing some pre-class activities like watching video lectures and completing quizzes. However, unlike the conventional flipped classroom approach, students in online flipped classrooms do not meet to meet, but online. Flipping the class effectively involves flipping teachers' as well as learners' mindset about online teaching and learning. Likewise, attitude plays a crucial role in the teaching and learning of mathematics. It is a key factor to be considered in understanding and explaining differences in student performance in mathematics. Hence, This study aimed to determine the online learning mindset, mathematics outlook, and academic performance of college students in a fully online flipped math course. Specifically, it sought to answer the following questions. First, what is the online learning mindset of the participants before and after the implementation of the fully online flipped math course? Second, is there a significant difference in the participants' online learning mindset before and after the implementation of the fully online flipped math course? Third, what is the mathematics outlook of the participants before and after the implementation of the fully online flipped math course? Fourth, is there a significant difference in the participants' mathematics outlook before and after the implementation of the fully online flipped math course? The fifth problem, what is the academic performance of the participants before and after the implementation of the fully online flipped math course? Is there a significant difference in the participants' academic performance before and after the implementation of the fully online flipped math course? Seventh, is there a significant relationship between the following: online learning mindset and mathematics outlook, online learning mindset and academic performance, mathematics outlook and academic performance? What are the realizations and challenges of the participants in a fully online flipped math course? Ninth, what are the suggestions of the participants in improving the implementation of a fully online flipped learning? This study employed a quasi-experimental design, particularly the pre-test post-test design. For the participants of this study, there are 33 first-year college students enrolled in Mathematics in the Modern World, utilized the fully online flipped learning, and those who completed the pre-test and post-test of the three variables. Data gathered were analyzed using the following tools. For online learning mindset and mathematics outlook, weighted mean was used. For academic performance, test score was used, and to determine if there is significant difference in the pre-test and post-test scores of the participants in the three variables, paired samples t-test was used. And for the significant relationship between the three variables, Pearson R was used, and a thematic analysis was used to determine the challenges, realizations, and suggestions of the participants. The flipped learning. The one question, what's the best use of your face-to-face class? Or we can actually revise this during this new normal. What's the best use of your synchronous online meeting? According to Flip Learning Network, Flip Learning is a pedagogical approach in which direct instruction moves from the group learning space to the individual learning space, and the resulting group space is transformed into a dynamic, interactive learning environment where the educator guides the students as they apply concepts and engage creatively in the subject matter. Two of the earliest advocates of flipped learning, John Bertzman and Aaron Sams, have described this approach to instruction as a strategy where work that was traditionally done in class is now done at home, and what was traditionally homework is now completed in class. According to Vanderbilt University's Center for Teaching, there are four key elements of the flipped classroom. First, provide an opportunity for students to gain first exposure to content prior to class. Second, provide an incentive for students to prepare for class. Third, provide in-class activities that focus on higher-level cognitive activities. And fourth, provide a mechanism to assess student understanding. Here are the four pillars of flipped. Flexible environment, which includes space, mode of delivery, and timelines for learning. Second, learning culture. The culture is learner-centered approach, which encourages deep learning. Third, there is intentional content, where the teacher curate or create relevant content and differentiate to make content accessible. And P stands for professional educator, where the teacher guides learning and continuously improves his or her practice. To answer the one question, what is the best use of face-to-face time with the students, or what we call the synchronous online meeting? The best use of class time incorporates enriching learning activities and relevant experiences. Why flip your classroom? Moving content delivery outside class frees up in-class time for collaboration, inquiry-based learning, peer instruction, and contact time between students and teachers. Content is available for review or remediation. It integrates well with the principles of universal design for learning, where teacher provides a multiple means of representation, provides multiple means of engagement, and provides multiple means of action and expression. Flipped Classroom is a pedagogical approach that cultivates student engagement and empowers students to be active learners. It's been said that the flipped model shifts the teacher's role in class from sage on the stage to guide on the side. Here are the benefits of the flipped classroom according to John Bergsman and Aaron Sams. Students can get help on difficult topics. The teacher-student interaction is enhanced. It allows for differentiation. It creates an atmosphere of learning. Students can learn at their pace. It helps when students are absent, as well as teachers. This is the flipped classroom model that I've employed in my class. There is the pre-class activity, the in-class activity, and the post-class activity. I did orientation and flipped learning approach among my students. I also created my own video lectures. Orientation is done in MS Teams. Announcements and instructions were also posted in MS Teams. The video lectures were uploaded in my YouTube channel, RB Space. These are the tools I've used in creating my videos: Open Broadcaster software, MS PowerPoint, and YouTube channel. For the lecture videos, these are the different parts. There is the learning outcome, problem posing to introduce the lesson, real-world applications were also used for the introduction of the lesson, and there will be activities to check understanding of the students at the end of each topic. At the end of each lecture video, a mindfulness exercise or activity is given to students. For the synchronization or the in-class activity, this is done through synchronous online meeting. So the first activity is a pre-assessment activity. Students were given a quiz to actually check whether they learned something from the lecture video. Then there will be problem-solving activities, formative assessment activity, and during the asynchronization or post-class activities, students will be given enrichment activities, other assessment tasks, and post-assessment activity. There will be also exercises for reflections and knowing students' learning insights. And of course, one of the most important part is providing feedback to students. As shown in the graph, the participants have positive attitude towards online learning before and after the implementation of the fully online flip math course. The test results indicate that the participants' attitude towards online learning have improved. Likewise, the graph shows that the participants have positive attitude towards mathematics before and after the implementation of the fully online flip math course. The test results also shows that the participants' attitude towards mathematics have improved significantly. The graph shows that the pre-test mini-scores reveals a satisfactory academic performance, while the post-test mini-scores reveals an excellent academic performance. The test results indicate that the academic performance of the participants have improved from satisfactory to excellent. The table shows that there is a significant relationship between online learning mindset and mathematics outlook, between mathematics outlook and academic performance. However, there is no significant relationship between online learning mindset and academic performance. After the fully online math course, the students have the following realizations. Students learn at their own pace, time and place, able to play, pause, forward, or rewind video lectures, maximizes student time through learning the lesson ahead of time, prepares students for the synchronous session. The following are the challenges encountered by the students: poor internet connection, too many school requirements, too much screen time, and limited interaction, especially during the pre-class activities. Students suggested the following for the improvement of the implementation of flipped learning: improve student time management skills, increase interaction between students and teachers, provide immediate and timely feedback, create more interesting and engaging video lectures, provide more examples for each topic, be more considerate for students with technical problems, and offer other accessible learning materials for all students. Based on the findings of this study, the following conclusion was drawn. Flipped learning is an effective approach in enhancing learners' attitude towards online learning, attitude towards mathematics, and academic performance even though it is delivered fully online. Learning environment that promotes positive attitudes in students is a key factor for successful online mathematics instruction. Flipped learning approach has increased students' motivation and confidence in learning math, improved their engagement in guided, independent, and collaborative in-class activities, and deepened their understanding of mathematical concepts. Hence, the flipped learning approach can transform classes into dynamic, engaging, interactive, student-centered online learning environment. Flipped learning is a tool in your toolbox. It's a very effective, powerful tool, but it is not the be-all and end-all. Flipping is an iterative process, so as you implement these practices, reflect on what works well and what needs to be modified. For teachers and students alike, the transition to a flipped model takes time, effort, and commitment. Are you ready to flip? Mabalo. Thank you.